Joining us today, we have with us Vern Tyndall from Cambium, who's going to do a presentation for us focused on applications for the municipal market with Cambium products. My colleague Steve Viles is going to do an introduction for us, and just a couple of housekeeping notes. The first one is I am recording the webinar, so afterwards I will send out a link to everybody with the video link to YouTube so you can watch it anytime you want. Second thing is I will be also, if you request permission, just send me an email. If you request a copy of the presentation, I can send you a PDF of the presentation. So just send me an email after the webinar. And then the third housekeeping note is regarding, well, actually the third and the fourth. You will be on mute throughout the webinar. So if you do have a question, there is a little option on the GoToWebinar console where you can submit a question. And we're going to be taking the questions throughout the presentation, so in sections. So you send them in, and I'll read them out as we get to the end of a section. And also, we will do questions and answers at the end. So without further ado, I'm going to hand things over to my colleague Steve, who's going to introduce us again. Thank you.
Hi, good afternoon. Again, Steve Viles with Alliance. I am responsible for the U.S. Central and Northeast, and going to be presenting this, or Vernon is going to be the primary presenter for the Cambium product overview. As far as the webinar today, we're going to be going over complete broadband solutions for both licensed, unlicensed, point-to-point, as well as some point-to-multipoint. And again, Vernon will be happy to answer questions based on the breakout of the slide deck that he's going to present. As far as Alliance, we're a full-line broadband distributor. We also provide complete wireless infrastructure products, large fiber provider, so anything and everything you need with fiber designs, installations. Alliance can support you on that and provide you with any sort of competitive pricing that you need. We also completely support all IDAS and ODAS applications. As far as Alliance, we're, again, a world-class distributor. We have inventory located in multiple warehouses located in Canada, the U.S., and also in Mexico. We provide complete pre-sales as well as post-sale support. Anytime that you're questioning a design or need some help with pre-engineering or pre-designing, we'd be more than happy and actually looking forward to anything that we can help you out with as far as designs, again, whether it's licensed or unlicensed, point-to-point, point-to-multipoint, or any sort of matching opportunities that you have. And again, we can go ahead and work with Vernon and folks at Cambium, as well as we have our own engineering staff within Alliance that we can help provide microwave path designs, work with a link estimator. We can pre-kit your solutions for you. So again, we provide complete power solutions, fiber solutions, infrastructure, any steel product that you might need. We can completely design any sort of tower that you need, or any other support that you have. Attached here is a list of several of our broadband manufacturers that we work with. Cambium, again, excellent manufacturer for point-to-point, point-to-multipoint products, and you can see we have some indoor solutions available. We have the full line of Tri-Line towers, Sabre towers. We do our energy solutions with Alpha, Eaton, Solus, and we have several others in addition. And then we have several indoor solutions that we can help build out your internal LAN also. If you'd like to look at any of our past presentations, please look at the website that I have attached here that provides all our past webinars if you're looking for something specific. You can also follow us on LinkedIn as well as Twitter. And without any further ado, I will turn this over to Vernon, and he will be able to accept questions based on his slide deck. And if you have any questions, just please type those out, and we'll take a look at those. Thanks very much.
Good afternoon, everyone. This is Vernon with Cambium Networks. I'm glad you could carve out a little time to come see what we have to offer specifically for the municipal space. It's not a new market for us. We've actually got quite a few success stories we'll talk about. And actually, there are a lot of success stories that we just don't possibly have time to cover with this webinar. With that, let's take a brief look at the agenda, and I'll let you read that while I introduce myself. I'm actually a regional technical manager, which is a mouthful way to say sales engineer for Cambium Networks. I'm based in Texas and generally support the Southwest, so I noticed this invitation drew a lot of people from the Northeast and Canada, and that's okay because our products work there just as well as they do down here. I've been with the company actually since before the company existed. Our products originated in Motorola, and about 4.5 years ago we divested as Cambium Networks. Since then we've had lots of major developments. We were smart enough to take all the really talented engineers with us, and we've got some great stuff that I'll talk about in the product overview. And then we'll cover some success stories and a couple of things I want to point out. I noticed there's a lot of integrators and VARs that showed up, and even for a municipality that's making the decision to deploy wireless, I think there's a few considerations that just need to be aware of before you start the deployment, and in a lot of cases before you've got the PO to buy the stuff. So with that, why broadband? Well, it surprises me today that people still have T1s in their networks, but there are a lot of T1s still in use just to connect remote buildings, to connect even some SCADA type stuff that generally the bill for that is a whole lot higher than the benefit to it. So with a broadband network in place, you can certainly light up those remote buildings with LAN extension. Another thing we can do is network backup. So Steve mentioned a lot of fiber offerings from Alliance, and that's great, but microwave point-to-points don't suffer from backhaul fade. So it makes a lot of sense when you have mission-critical operations to actually have some network backup in place. Now, one of the hottest topics these days is video surveillance. In fact, most of the success stories I'll highlight today have a video surveillance component to them. We also do a lot of traffic monitoring and control. We've seen a lot of that, and the benefit of lower cost radios is you can quickly deploy these networks and actually come up with a budget to cover the cost. While we're building these, we also need to think about network security. You know, if you're using lease lines or some kind of third-party internet connectivity to tie buildings together, that traffic's traversing outside your network. It makes it a little bit more difficult to control the security, and that's something with a private network you can certainly control all aspects. And the last thing to say, this single network serves multiple needs, and that's something I'll highlight as we talk through the success stories about how some of these municipalities started out with a need for video surveillance in one area, and then the water department found out, and then the traffic department found out, and that's just something to keep in mind as we move forward and talk about putting broadband wireless in a municipal network. Probably not any questions so far, so I'm going to go ahead and kick off a quick product overview. Now, one thing I'll say about Cambium Networks, we have a very broad portfolio, so a thorough product overview would probably take more than the time allotted for this webinar. So with that, I'm just going to touch lightly on things, and at the end of this section, I'll open up to see if there's any questions about our products. So our vision and mission, Cambium Networks' motto is connecting the unconnected, and to do that, we need to wrap everything up with a good, solid, single management interface, management system, and we need to offer all products in the portfolio. I mean, from high-speed licensed microwave point-to-points down to Wi-Fi that you might put in a guard shack. We cover all of that, and we're headed toward having all of it in the same management interface, so a single pane of glass, you can manage the whole network. And of course, keeping it easy to operate. That's really important. What I see with municipalities versus a service provider, the IT staff or the water department or whoever's running the network, they don't necessarily touch these devices every day. So it needs to be simple so that 6 months after it's installed, if they want to go check something, it's easy enough to get in and go look. So a quick look at the end-to-end idea. If we look to the left of the screen, we have, again, multi-gigabit licensed microwave products. So that's a good option for those fiber backups when we're doing the network backups. And we do have license-free as well. So I know the licensed microwave is a little expensive in Canada, where the licensing costs are actually based on how much bandwidth and how and they're renewable annually, things like that. It's a little better down in the U.S. where we get 10-year licenses at a fairly modest fee. And with that, we do have license-free point-to-points that are good up to about 450 meg. So still really high throughput, still capable, and no hassles of licensing or managing the licenses. Now, in the middle of the screen, you see our point-to-multipoint platform. And this is really where I started with Motorola, was with the point-to-multipoint gear. Since then, we've evolved to offer some really fascinating products and some really cutting-edge products. We also have some very low-cost products that we just put in the mix. All of these are proprietary technology, and part of that's because we haven't found a standard yet that meets the cost-effective / performance curve that we need. So today we're still using the same proprietary protocol, and it's working very well. And we can also still make the claim we offer the most megabits per square mile in the multi-point arena. Now, new to us, but certainly not new to municipalities or any enterprise, is Wi-Fi. This was a piece that up until about a year ago was really missing from our portfolio, and we've since added quite a few devices, including a small home and business Wi-Fi router that also has 2-port ATA, and interestingly enough has PoE on the WAN port to power a point-to-multipoint device to connect back to the network. And since outdoor is our game, we had to have outdoor Wi-Fi access points, so we do offer those. And of course, indoor, we have a really nice 802.11 AC offering there. Now, to dig a little deeper into the high-end licensed microwave, we really have 3 different subcategories of the PTP 820. The first is the 820S. This is actually a fairly low-cost, high-speed microwave radio. So the narrow radio is capable of 500 meg, wide 600 megabits, and that is with a single radio core and a single Cat5 coming down the tower. It's an all-outdoor unit, simple installation, and fantastic performance. Its big brother is the 820C. Again, full outdoor, but this one has 2 radio cores in it. So you can actually double those throughputs that I mentioned, and that's just by enabling the second core and using internal link aggregation so that you get a true gigabit copper wire coming down the tower. Now, if you configure it with wide channels and you have 1.2 gig, well, it only has gigabit ports. So to get the full 1.2, you do have to run 2 cables down the tower, and you'll end up with 2 600 meg connections. And lastly is the split mount architecture. So this is the 820G, and this is more of a transition radio in my opinion. Some people really like the split mount architecture, but what this brings to the table is legacy T1 migration. So this radio is capable of native Ethernet as well as native TDM traffic. Now, one nice thing about this, the T1s can either be configured as native wayside T1s, or they can be configured as an IP MUX. The benefit to the IP MUX is you don't have to drop it off at the other end of the link. You can drop it off at any other radio that can route IP to it. The downside is slightly higher latency on the T1. For sub-6, we still have a pretty big portfolio, all the way from the low-cost PTP 450. This really is a fantastic low-cost radio for maybe connecting a building that's across the campus, or places where you need a modest amount of connectivity but good reliable connectivity. The next step up from that is the 450i. The 450i really is a similar platform to the 450, except we've industrialized it. So if you have a location where you're concerned about the environment, the 450i is the perfect fit. In fact, we have an ATEX HASLOC rated version. So for the U.S., a Class 1 Div 2, not sure what that is in Canada, but it's a fantastic radio when environment's a concern. It also has much more processing power, so the capabilities for packets per second, things like that, are much, much greater. Now, step into a little bit of a different technology, base technology, is the PTP 650, and that does come in 3 different flavors. So there's an S that was specifically developed for small cell backhaul. It's integrated with a small 19 dB antenna, and one of the goals of that particular unit was to be able to make it disappear when you're deploying it everywhere. So small form factor, something that can be easily hidden. And there are connectorized versions, and we have connectorized links with large antennas going long distances, carrying, 400, 450 megabits of traffic. And the newest and latest addition to the sub-6 point-to-point portfolio is the PTP 700. Not much of an interest probably for this group. It does have some neat advancements in it. One is it supports high-capacity multipoint, which is not the same as our point-to-multipoint products. It actually is a method where we can provision a certain chunk of the spectrum for multiple connections. So instead of having a point-to-point where one radio talks to one, we basically set up this high capacity where one radio can use 10 megahertz of spectrum to talk to one and another 10 megahertz to talk to another, and we end up with super low latency, high capacity links in a multi-point scenario. There's lots of limitations to that. We have to do some beamforming to steer the antenna and a few other things, so it's limited to about 8 connections. But for video surveillance projects, it's actually pretty handy because you can have such high capacity and dedicated capacity to a lot of these remote video cameras. Now, that technology has been pulled into a new sub-6 radio called the PTP 670, which the PTP 700 is really focused for DoD bands. So the bands it operates in are generally not available to anyone outside of the federal government. But the PTP 670 will use that same technology and be offered in the typical 5 gig license-free bands. I should also mention that the PTP 650 is a wideband radio. So in fact, the 450i and 650 both support from 4.9 gigahertz to technically 6 gig, but for most of us, 5.8 is the band where we stop. Now, for point-to-multipoint, this is, I actually had to trim this slide down to get rid of some of our legacy products. We always like to show the legacy products because we still have some of them in operation. We have a PMP 100 that was originally introduced in 2002 by Motorola, and we actually still have some of those in operation in the field. They're just chugging along and carrying bits. But they're also end of sale, and so we don't sell those anymore. I didn't feel it was appropriate to have them on the slide deck. What we do sell today is the PMP 400 series. Now, the 430 probably shouldn't be on this list because it's, while I don't think officially end of sale, I think there's no reason to buy it when there's a PMP 450 available at the same price with greater capability. But it does help show the natural evolution of our products. So if we consider the 430, it was available in 5.4 and 5.8. It would run in both of those bands with a single SKU. About 50 megabits per sector was what it was capable of. And it was a good workhorse of a radio. Reality is we're always striving for more capacity, and that's when the 450 PMP 450 came out. And you'll notice 125 megabits per sector, significant bump. Past that, very similar radios. Now, the next evolution is the 450i. So not only did we industrialize the housing and make it more rugged, We also added a wideband filter on the front end, so it does support 4.9 through 5.8. We also added a dynamic filter, which improves the link budgets. It helps cancel out noise, and we did improve receiver sensitivity as well. With that, it's still 125 megabits per sector, but that's because it's backward compatible with the PMP 450. And in fact, PMP 430 subscriber modules can connect to a 450i access point and carry bits. They can't go at the same speeds, but they can still connect. Now, the last piece of the 450i that we added was 900 megahertz, and I've sort of put that off on its own because it does have some unique characteristics about it. One, it only runs in the 900 megahertz ISM band, which is a fairly small band, but you'll notice the maximum Ethernet data rates are still big. Now, it's only capable of 125 megabits per sector if you use a wide channel that consumes almost the entire 900 megahertz band, so it's not typical for people to actually do that. Typically, the radios are configured to use a narrower chunk of spectrum, and because of that, a typical throughput is about 40 megabits per second. And this one actually does have, we've actually recently deployed a few of them that hit the internal timing limitation of 40 miles. There's plenty of link budget for them to go greater distances, but because of the way we time our frames, they are limited to 40 miles. And you'll notice the non-line of sight capability. The 900 megahertz, I list that as extreme because not only does it have the MIMO OFDM technology that gives the 5 gig radio non-line of sight capability, it's also at 900 megahertz, which has a tendency to go through things instead of bounce off of things. So the non-line of sight capability is extreme. It's very, very functional. Of course, since we added Wi-Fi, we should talk about that a little bit. If you notice on the left, there's the R200, 201. Those really were targeted at the internet service provider. This gives an ISP an opportunity to put in a Wi-Fi router with their service that also has 2 ATA ports, so it has 2 FXS telephone ports. Now, what we've noticed is it's become kind of exciting for some municipalities because there's always a guard check. There's always this remote outbuilding with the water department that could use a phone line and some data connectivity. And it turns out this small $100 unit is actually the perfect fit for that. Next over is our indoor E400. That is 802.11ac and a dual band 802.11ac radio. And one thing I was concerned with when Cambium Networks first introduced the Wi-Fi portfolio, my fear was that we would have something that was really lacking in features, that would just, we would be behind the industry. And that's not the case at all. These Wi-Fi radios are very, very feature rich. They offer things like simple splash pages, multiple SSIDs. Probably the easiest hotspot I've ever set up is built into the radio. So all of those features were available right out of the gate. And so far with all the testing I've done, they work really, really well. Now, the ePMP 1000 hotspot, interestingly enough, this hardware is based on one of our low-cost Multipoint radios. It's the exact same hardware. We load Wi-Fi software on it, and it makes a really nice, inexpensive outdoor hotspot. It's still band 802.11n, and it's available as N2, 4, or 5 gigahertz. And the latest edition is E500, which is pretty high-performance outdoor integrated radio. So 802.11ac dual band, IP67 housing, and is an Omni antenna in that square box. So it gives really nice coverage pattern at a really low cost with lots of good performance. Be great for lighting up parks or fairgrounds, things like that. And of course, to tie the portfolio together, I talked about having a single pane of glass. That is CN Maestro. And CN Maestro, really our goal there was to not only put everything under the same pane of glass, but make it simple and make it scale. So one of the things we've seen with even some of our previous management system offerings they had serious limitations when it came to scalability. Once you hit a certain number of devices, you just couldn't buy a server big enough to keep them running. And with Maestro, the goal was, instead of scaling to thousands of devices, to be able to scale to millions of devices. And that's because the first release was available only in the cloud. In fact, today I could say it's still only available in the cloud, but the on-premise release is in beta. So it's soon to be available for on-premise installations. And just to give it a quick look, you can quickly define devices. It does good inventory management. The very first dashboard gives you a quick look of any issues. You click on those and it'll take you straight to where the issue is. And you can, of course, sort things on your own, but it does automatically connect things together logically. So if a subscriber connects to a base station, those will automatically be associated in as you drill down to look through the menu. So any questions on the portfolio, Lisa?
Sorry, I had myself muted. No, there haven't been any questions so far. Does anybody want to submit any? Okay, I'm not seeing anything, so let's carry on.
All right. So let's take a quick look at some success stories. And these are not necessarily recent deployments. Some of these date back a ways, but the first I'll talk about is the city of Green Bay, Wisconsin. And they had an issue where they had some high crime areas and they needed a way to thwart that. So video surveillance seemed like the nice answer to it. And in fact, it generally is. Now, between us, generally you can put up a surveillance camera with no connectivity to it, and that will suppress bad behavior. But that's not good enough whenever you actually have to take someone to court. So they needed connectivity, and they needed it to be reliable, and they were in a crunch to actually get this out quickly and on a small budget. That's where we came in. We gave some point-to-point radios to backhaul certain towers that were going to aggregate this video, and point to Multipoint to reach from these towers down to where they wanted video cameras. Now, these guys couldn't take advantage of it, but the new 450i does have 2 Ethernet ports in it, and the second Ethernet port has 802.3 AT power output on it. So it is realistic on these future installations to just connect an IP camera directly to the radio. No need for another cable running down, no need for Ethernet switches. Just plug it in and deploy. Quick, rapid installation. City of Palm Beach, Florida, sort of the same thing, only they wanted it for automatic license plate recognition. Always makes me a little nervous to sneak through a yellow light that's a little bit maybe turning red, that there's always automatic license plate recognition out there, but that's what they needed it for. And it does see license plates and translate them into numbers that can be searched in the database. It's a really neat system. But for it to work, it needs a fairly high amount of capacity. I mean, it actually takes a fair amount of throughput to carry all these video images back for the analytics to process them. And that's where we were able to provide that with a high-end point-to-point licensed microwave backhaul to tile the infrastructure, and then 450s, and I think they're actually transitioning 450Is now to keep the capacity up to the actual cameras from the tower. They were, and I take that back, these were PQP 650s because they could not use licensed radios, so they had to use unlicensed bands. For budget reasons and contract reasons, they actually couldn't get licensed microwaves. They couldn't use those because of the way their budget cycle works. It was a quick deployment. The install went quickly, and as far as I know, so far they've had no downtime. They're just recording the license plates and probably writing tickets. Now, Seattle is one that I'm going to be a little more familiar with because I actually started working with these guys a little over 5 years ago when we were still part of Motorola. And this is one where it did start out as a video surveillance application. And this is also one where once a lot of video cameras were up and the network started growing and getting connectivity to a lot of locations, the water department went and knocked on their door and said, hey, can we tie in some of our sensors over this? And the next thing is the traffic department steps in and says, hey, can we control traffic lights with this? Can we connect all of that in? And absolutely. In fact, the last conversation I had with the guy that was running the network was, hey, how do I do all these VLANs to separate all these departments? All these departments want to use it, but I need to keep all of them separate. And the radios certainly support that. In fact, the Multipoint radios support not only 802.1Qs to VLAN separate them, but we also support Q and Q, which ended up being a necessity because one of the departments carried multiple VLANs on their own already. So the nice thing about our portfolio is it's very mature. We're on version 14. We've been doing this for 14 years, and because of that, it's very feature-rich and capable whenever you run into a networking issue like that, where you need something that maybe a lot of manufacturers don't provide in their solutions. Now, another thing that was critical for them, the spectrum is not necessarily clean in Seattle, Washington, so they did want to use 4.9, and the 4.9 spectrum is only 50 megahertz. So to start trying to do huge amounts of radios with only 50 megahertz, it's sort of self-limiting if you don't have some methods to reuse frequency. The point-to-multipoint portfolio has always been GPS synchronized. We've always had plans for frequency reuse, and we actually have some other things in our Mac that make optimizing the number of subscribers per access point, make that number go up. And that was critical for the city of Seattle because, again, they had a lot of stuff they wanted to do with just a small amount of spectrum. Hackensack University Medical Center, this was an interesting thing where they had a sports event and they wanted to set up a mobile sports event. You saw the logo there, but anyway, I'm not sure I can actually say it without breaking some copyright. But they needed to be able to perform high-end medical operations, surgeries, but things like x-rays, diagnostic imaging, things like that at the event. And of course, by the time they decide to do this, the clock's ticking and the event's rapidly approaching. So we were able to, with license-free, give them quick installation and give them enough connectivity that they could do all the things they needed to do as far as sending x-rays to doctors for looking at other test results. They needed voice, so they needed to be able to have conversations with staff back at the hospital. All of that was done with a PTP 650 link. Now, what we can do, we didn't on this installation, but what we can is use automatic positioners. So we have a relationship with BATS, which is the Broadband Antenna Telemetry System, where we can put PTP 650s on their units, and basically this mobile hospital could drive just about anywhere within what physics allows for the link to get back to the tower, and the BATS unit would automatically align the radios and the link would be up. It's not an inexpensive solution, but it's a really neat solution for mobile command vehicles or mobile medical stations like this. In Wayne County, New York, this is another one where it started out with one need, and actually this one before the network was deployed, all of the other departments had started coming in saying, hey, can it do this? Can we add this on? Can we do this? The original need was for emergency 911 services to be able to backhaul some of these 911 facilities and some of the actual radios that carried the 911, which includes VoIP for connectivity. But then, hey, can we do video surveillance also? And hey, at these remote locations, can we go ahead and transfer files back over this network because it's fast? And we were able to pull that off. So they did have some wireless broadband in place. It didn't have enough throughput. So the PMP 450i was the solution for the Multipoint system. and of course the PTP 650 that operates in 4.9 as well, help tie it all together and get them everything they needed to run all of their applications. How about any questions now, Lisa?
Sorry, no questions.
Well, I must be doing a good job, so no questions so far.
All inclusive, yeah.
So, you know, it all sounds great. Let's go get some radios and throw them up, and we'll solve all of our problems. And that's really not the place to start. So I really do want to point out some considerations for successful deployment. You know, to put it in perspective, I was with one customer, this has been a few years ago, and he saw the marketing spec sheet that said we were capable of 40 miles. And it was a platform that actually supported non-line of sight. What he read was 40 miles non-line of sight at the highest throughput. Well, you know, there's marketing and then there's physics. So everything on our marketing sheet is absolutely true, just can't always put it all together in the same statement. So proper RF planning absolutely should be done, in my opinion, oftentimes before purchasing the equipment. It's nice to know this stuff's going to work before you actually go spend the money and have it sitting in a warehouse waiting to be deployed. The nice thing is Cambium Networks has the tools you need for that. We have a program called Link Planner. It is a very handy tool for doing both point-to-point and multi-point analysis. So for point-to-point, any of our point-to-point products can be put in. You know, you tell it the ends of the link and tell it to create a link between them. And from there, it'll give you really good performance predictions. So not only availability, but throughput as well. All of that will be calculated, and you can actually see the terrain between the two sites and have some confidence level that this is going to work before I deploy it. Same thing is true for multi-point. Maybe don't get quite as much output from multi-point, but typically you don't need as much for multi-point because of the nature of multi-point. But at least you can do propagation analysis. At least you can know that these locations are going to work before you buy the radios. And possibly you may have to take steps. You know, if it's a committed project, there's always things like raising the tower a little bit, getting better line of sight to a remote location, things like that. All of those what-if analysis can be done with Link Planner as well. And I'm in Texas right now. It's supposed to be 100 degrees outside. I would much rather be doing what-if, sitting at my desk under the air conditioner than outside scratching my head in the sun. Another thing is capacity planning. And this is something actually I get to revisit frequently because, like I mentioned with the city of Seattle, we put it in for video surveillance. It was originally designed to carry these video cameras, and it seems like right as you're starting to build it to as designed, someone knocks on the door and says, "Hey, can I do this with it as well?" And what I would say is, if you're planning a network deployment, don't design it for the capacity you need today. Look a little bit in the head, at least more than one budget cycle down the road, and make sure you design it for capacity that you'll need tomorrow, not just today. Again, we have tools for that. Link Planner can give a pretty good capacity analysis, but for just a quick yes or no answer, we also have Capacity Planner, which is a spreadsheet that just does math. So it doesn't do a lot of analysis, doesn't do a lot of RF analysis, but it does quick math. So just to answer questions, you know, what kind of range can I get with this band? What kind of capacity can I expect in this deployment? Those are the things that it hands out quickly and easily. And probably the most important is proper network design. Our point-to-point radios, most of those can handle packets at wire speed all the way to their capacity, and you know, that includes the 650 and the 820. Those guys can run full capacity with 64 byte packets, and they operate great. Unfortunately, on the multi-point side, certain things like broadcast traffic is very demanding on a multi-point network, and this isn't something that's limited to our protocol. It actually is true on Wi-Fi, it's true on WiMAX, it's true on LTE. The shared medium doesn't handle broadcast traffic as well as a wired connection or a point-to-point. And that's the nature of the beast, because we are essentially a big switch, and if a broadcast packet comes in, we have to assure that everyone gets it. And to do that, we kick the radios to the lowest speed, and we actually repeat those broadcast packets. What that means is broadcast packets are very, very costly to carry on the multi-point network. So that's why my first bullet is limit broadcast domain. I've walked into networks, I won't mention names of any towns, but they were giant layer 2 networks. And in fact, the subnet they chose was a Class B. And when I asked, hey, why did you choose this giant Class B scheme? They said, well, we got a lot of devices out there. Oddly enough, their multi-point network was struggling a little bit, and whenever we went and looked, about 45% of all their traffic was ARP requests, just from computers sending out ARP requests for their gateway. And all of that traffic contained, once we actually put in some routers, we actually started limiting the broadcast domain, its capacity dramatically improved. In fact, I don't think they've amended the system since then, and that was about 3 years ago. Also, because of the cost of these radios is relatively low, even our highest end PTP 820 is very, very inexpensive compared to getting out the trencher and laying fiber. So it makes a lot of sense to build some redundancy into the network. Now, the redundancy doesn't have to be wireless. As mentioned early on with the network backup, having a licensed microwave in conjunction with fiber makes an awful lot of sense. Different issues affect those two different mediums differently. So, but setting it up so that it's dynamic, so that it automatically fails over, so that the network is resilient. That's a really important thing to consider when you're designing the network. Also, multicast traffic is something that we see a lot in these video surveillance applications, where they actually set up the cameras to send out multicast streams so that multiple different network video recorders can grab the video. And that's a really good installation. I mean, I like the practice, but you certainly don't want multicast traffic flooding all over the entire network. It doesn't take very many cameras sending out multicast streams that go everywhere on the wireless network to just bring the network to its knees. So it's really important, if you're doing multicast, manage where that traffic goes and don't necessarily allow it to go over the entire network. And then lastly, security. Security has to be the top concern when you're putting these together. There's a little bit of apprehension about wireless because people think it may be a little less secure. The reality is all of our products have really advanced security methods in them, and in fact, the proprietary nature of our Mac does give one more level of security. So we can securely configure the wireless interface. However, we still need to consider things like the physical access, overall network security. When I connect to the internet, am I secure on that connection? And that is it for me. So hopefully there's some questions now.
Yep, I do have one question. Any comments or guidance regarding the PMP 450 versus the new ePMP 2000 for small rural deployments?
Sure. It depends on your budget and what your expectations are. So ePMP, in general, the product line as a whole, was one of the primary drivers in its development was low cost. We wanted to get a unit out there that was affordable for people that have small budgets. And we achieved that. Now, while quality is certainly at the top of our minds, we don't ever want to turn out a product that's low quality. And I've got to point out that we did have to use commercial components to get to that price level, whereas the 450, 450i, those use industrial components. So what you'll notice is the spec sheet for the temperature range is narrower on the ePMP product line. You'll also notice that the MTBF numbers aren't as high. Now, as far as performance, both platforms perform very well. in certain situations, EPMP will outperform the 450. Generally, those situations are where there's a really low subscriber count, so very few remotes connecting to the tower. Considering spectral efficiency, the 450 line always wins. In fact, it's about a 1.5 times better spectral efficiency, and that's just because the 450 being based on an FPGA, we totally control everything about that radio. So when we're in a receive cycle, we actually turn transmitters off. When we're in a transmit cycle, we turn receivers off. Because of all of that, we don't need guard bands between adjacent access points on a tower, and that factors into overall tower spectral efficiency. So in congested spectrums, 450 platform still wins. Now the 450 or the EPMP 2000, which is really an access point introduction to the portfolio, does have the beam steering for uplink, and it's actually really fascinating technology. There are active amplifiers on a secondary antenna you can use for uplink, and those amplifiers are fired in order because we know where subscribers are and when it's their turn to talk. We actually fire the amplifiers on each element of the antenna so that we phase that uplink from the subscriber to get the best signal and reject stuff that's going to be in different directions. And this is really impressive and really does help for eliminating or dealing with interference. Something that we actually will announce next week is the CN Medusa platform for the 450 that has similar capabilities but more. So from a future-proofing perspective, the 450 still wins. Hopefully that answers it.
Okay, I've got a whole bunch of more questions coming in. Hold on a second. Okay, I think this might be related. What about real-time video conferencing, end-to-end, and latency or jitter successes, i.e. for remote doctors on demand?
Yeah, that's something that's actually very critical and maybe not often mentioned. Jitter, when we start doing, so video surveillance isn't so jitter sensitive. In other words, if the latency varies a little bit, it's no big deal. The frames make it in. Voice, on the other hand, is very sensitive to jitter. And that's one beautiful thing about the multi-point media access control we use, is that we control when things happen. So as long as voice is prioritized, the jitter shrinks to less than 2.5 milliseconds. In fact, typical jitter without prioritization is 2.5 milliseconds. Most common with prioritization, we keep the voice down to less than a millisecond of jitter, which is huge. Now, that's only at the last mile connectivity. From there, you said end-to-end, so we have to consider everything in between, which might include backhaul radios. Those radios, the PTP 650 has a very solid prioritization mechanism, and the PTP 820 actually has hierarchical QoS with frame cut-through. It has a lot of options for making sure that the jitter for voice traffic is really low. Now, I keep saying voice traffic, but that is the sensitive piece, even on a video conference. Voice, our ears are a lot more sensitive to defects than our eyes are. And with the 820, you can manage that so that even if there's a frame that comes in out of order, it can actually do a cut-through and make sure it makes it through the other side. Another thing about the licensed point-to-point, we don't measure latency on that platform in milliseconds. We actually measure it in microseconds. Zero distance latency is about 150 microseconds, and add another 5 microseconds per mile because it takes time for the RF to travel.
Okay, ready for another one? Yep.
Yep.
Which product would you recommend if you wanted to primarily do a P2P, point-to-point, but also have the capability to use as multi-point as well?
I don't know that I would really limit myself to one. I think depending on the application, the P2P 670 really excites me with the high capacity multi-point. So if I were doing, say, a campus video surveillance project, I really like that radio because I can do those high-capacity links, and I don't have to worry about I don't have to worry about congesting the pipe like I would with the lower speed multi-point radios. And it is point-to-point capable as well, so just configuring it for not configuring the high-capacity multi-point is sort of set up. But really, I don't know that I would pick one product as the Swiss Army knife. There's a reason we have a wide portfolio, and I think matching the product for the application just is the way to go.
Okay. So far, last question. Is there any solution for the 100-meter distance limitations associated with Ethernet and PoE over Cat5e cable, i.e. for distances greater than 100 meters up to 200 meters or beyond?
Yes and no. So yes, depending on the platform. So PTP 650, PTP 800 both have fiber ports, or they have SFP cages where you can add a fiber port. With the PTP 650, you can actually go 300 meters over the Cat5 so long as you're not carrying data. You're just using that to power the unit. And with the PTP 820, it's realistic to get the power closer. So you actually could carry the power with heavy gauge cables to a power injector, and then use fiber for the data connection. Now, I have seen PoE repeaters, so mid-span PoE repeaters, and I've had a couple of customers comment that they work really, really well. The problem with that on our base stations, so we rely on pulsed power for GPS, I mean on the 450, on the 450i. If you use the mid-span injector like that, well, we'll get the power there, it won't carry the pulses to it. And in fact, one customer reported if he was using the CMM as the power source, which does pulse the power, his mid-span devices would just shut off and wouldn't actually work. In that situation, these mid-span devices can still work, but you would have to use an alternative GPS connection. So using the universal GPS, actually tower mounted and connected directly to the access points would be the option there. So generally speaking, I kind of like to keep things within that limit, but sometimes when you're up against the wall, there has to be a solution, and really those are the solutions I've seen is using fiber or these mid-span injectors.
Okay, well, that's it. We don't have any more questions, so I'm going to say thank you very much to Steve and Vern, and thank you to everybody who attended today. I did record the webinar. Oh, one more quick question. Do we need to purchase the survey software separately?
The link planner software it's free. Actually, if you visit cambiumnetworks.com and go to our, there's a place there directly where you can download Link Planner, you can download Capacity Planner. Those are both free tools. The thing about Link Planner, we do keep counts of people that are using it, so it's free, but I get a report that says, you know, somebody in Texas did this many links, and there's a possibility a salesperson could reach out to you, but other than that, it's certainly free, and we generally don't harass people that use it. Okay, great, thanks. You know what, I'll after the webinar, I will send out follow-up emails to everybody, and I'll include a link to those downloads. And like I said to everybody, if you do want a copy of the presentation, just send me an email. When you get an email from me, just send me an email back saying, Lisa, I'd like a copy of the presentation. There will be a link to where you can watch the webinar as much as you want, and keep your eyes on email for follow-up. I'm going to be doing another webinar with Cambium. I'm not sure what the topic's going to be, but if you have any suggestions, I'd like to hear it. So thanks again, everybody, and have a great day.